Welcome to the course on computer architecture and organization. In today's lecture series, we are going to see about the introduction to the world of computer system. We may think that this field is a dry field where the progress is glacial, but computers are the products of the vibrant information technology industry. It is a vibrant field and knows it is a very important field for economic development because almost half of the economic development is based on this computer industry. This rapid improvement in information technology is already promised by this Moore's law. So who is Moore in this? Who is Moore? He is one of the founders of the Intel. He framed a law. So what this law speaks is that the resources on each chip doubles or quadruples over a particular period. So he framed a law and he depicted through a graph. So Moore's law is being promised and it is being fulfilled nowadays. So regarding many applications of this area, we find very important application areas of computer, or we may say that computer industry has taken a new vein of scientific investigations in these following application areas like astronomy, biology, chemistry and physics. We know that the computer revolution always continues. We may think that the cost of computing may increase. If the cost of computing improves by a factor of 10, suddenly the opportunity for computers multiply. So the applications that were economically infeasible suddenly becomes practical. So in the recent past, the following applications were considered as the computer science fiction. The first application is the computer in automobiles. Until the microprocessor has developed dramatically in the computer industry, one might have thought that if you want to control the car with the computer, then it will be ludicrous. Everyone will be lost. How can we control the car with the computer? But nowadays, this computer play a very important role in reducing the pollution and in improving the fuel efficiency via the engine controls and increase safety through the blind spot warnings, lane departure warnings, moving object detection, and air bag inflation to protect the occupants in a crash. And the second important science fiction is cell phone. We are all living with a cell phone in our hands. Who would have dreamt that half of the planet will be having these cell phones one time? So today we are having mobile phones, usually the small phones in our hand, and we are having the world in our hand, that is to speak. And the third important computer science fiction is Human Genome Project. This project maps and analyzes the human DNA sequences. Of course, the project cost hundreds of millions of dollars, and the computer that does this job will cost more and more, that is 10 to 100 times higher than the cost of computing. But today the cost continues to drop. We will be able to acquire our own genome, allowing medical care to be tailored to us. And the next important computer science fiction is World Wide Web. So without World Wide Web, we can't live. The web has replaced these libraries and newspapers nowadays, as we all know. If you want to search anything or if you want to expose or publish something, suddenly we need the help of this www. And the last but not the least, this computer science fiction is search engines. As the content of the web grew in size and in value, finding relevant information is the main task. So today many people rely on search engines for such a large part of their lives that it would be a hardship to go without them. So these hardware advances have allowed the programmers to create wonderful, useful software, which explain why computers are omnipresent nowadays. So today's science fiction may become tomorrow's killer applications. For example, already on their way are glasses that augment the reality, and the cashless society, and the cars that can drive themselves. Next comes the classes of computing applications. We have a very common set of hardware technology. So depending upon the application and the design, the hardware technologies are employed in these applications. So according to the need, or according to the design, or according to the application design requirement, these set of hardware technologies are employed in different ways. Usually there are three classes of computing applications which are textbook speaks. The first is the personal computer, and the second is server. Supercomputers come under the classification of servers. And the third is embedded computers. So we all know about these personal computers which we are using it extensively. This personal computer, what is the job of the personal computer is that it delivers a very good performance to only single user at low cost. Also, this personal computer execute the third party software. And the second important thing is that servers are nothing but the large computers, and it can be accessed only via the network. So servers are intended to do a particular job. Servers are oriented to carrying very large workloads, which may consist of either single complex applications, it may be a scientific or engineering application, or it may handle many small jobs like building up a very large server. These applications are usually based on the software from another source, but they can be modified or customized for a particular function. Servers are nothing but a simple desktop computer as we see, but it has a very greater capacity, that is the input and output capacity, larger storage, and it has a greater computing ability. That is the basic difference between the PCs and the servers. And important point about the server is that it has a very greater emphasis on dependability. So what is dependability in this context? In the sense, dependability is nothing but a crash in a system. So if a crash occurs on our own PC, it costs less, whereas if a crash occurs on the server, it costs more. So it has a greater emphasis on dependability, rather than it could be on a single user PC. Also, the servers span the widest range in cost and capability. There may be low-end servers as well as high-end servers. Low-end servers are typically it is used for the file storage or some small business applications or simple web serving. But at the other end, if you see the supercomputers it consists of tens of thousands of processors, and the memory range is of terabyte. And of course, because of this memory capacity and it has the capability to do great jobs, it may cost more. So supercomputers are usually used for high-end scientific and engineering calculations. Say for example, if you want to calculate the weather forecasting, oil exploration, and protein structure determination, like this large scale problems, if you want to calculate these type of things, then it can be computed or calculated only by supercomputers. So supercomputers represent the peak of computing capability, but whatever the peak of computing capability it speaks, it has a very less impact in terms of total revenue. The total revenue is very high for PCs rather than the servers. Okay. And the third important classification is embedded computers. Embedded computers are the largest class of computers. It has a wide range of applications and performance. So embedded computers, say for example, we are having the microprocessor in a car, and as in television set we are having some computers, and if we want to control the aeroplane, we are sitting in a room and controlling the aeroplane. These are all done through the help of this embedded processor. So these are all the examples for this embedded processors. Embedded computing systems are designed to run one application or one set of related applications that are normally integrated with the hardware and delivered as a single system or single device. So it may have a single device. It is capable of doing many applications or the set of related applications, and these applications are often integrated with the hardware. So this is the overview of the embedded computers. So most of the things we are seeing in a day-to-day world, what are all the home appliances, what are all the digital appliances we are seeing inside the home, it falls under the category of embedded computers. So many people doesn't know they are working on embedded computers. So that much level of growth it has attained. So these embedded applications often have a very unique application requirement. It doesn't demand anything that is complex. It just demands a very simple requirement, that is the basic requirement, which is nothing but it needs to achieve the performance correctly. If it does one job, that one job should be done correctly. So that is the maximum requirement of an embedded application. Take a music player. It is an example for an embedded computer. The processor just need to be only fast as necessary. The other side is cost and power that we need to concentrate. But the main task of this music processor is to play the song that you are recording or playing should be correct, should be in correct speed. So that is the maximum requirement of the music processor. If you see about this consumer oriented embedded applications such as the digital home appliances, dependability is just achieved only through simplicity. So dependability, already we have discussed that it is a crash in a course, crash in a system. So dependability is achieved primarily through simplicity. That is nothing but the demand is that the one function should be performed correctly by the embedded computers. So it is very simple because it just want to do only one function as perfectly as possible. So dependability in embedded computers are often achieved through the simplicity. In large embedded systems, if you take a very large embedded system may include more and more number of processors. So the techniques of redundancy from the server will be employed. So almost in this course, if we focus on general purpose computers, most concepts apply directly or with slight modifications. It is applied to embedded computers too. So welcome to the post PC era. We are all in the era of post PC. So if you see this graph depicts the manufacturing of the number of PC, tablet and smartphone sales per year. So this graph compares the manufacturing of the number of tablet, PC and smartphone with the manufacturing of cell phone. So if you see the graph, the manufacturing of cell phone has declined and the manufacturing of smartphone and PC and tablet is taking the breathtaking rate. After this PC era, we are in the era of personal mobile devices, that is PMDs. So PMDs are nothing but the cell phones or smartphones we are having in our hand. We all know that it is operated by battery, so it is a battery operated, and we can connect to the internet wireless. It has this wireless sensitivity and it costs some thousands. So it is very easy to purchase for a middle class family too. So this personal mobile devices has a greater impact in today's human community. Unlike PCs, they don't have any keyboards and mouse, but they rely on a touch sensitive screen or even speech input. So today's PMDs or smartphone or tablet computer, tomorrow it may also include some electronic glasses too. Talking over this servers, we must talk about this cloud computing. This is not a traditional server, it is a modern server. So cloud computing greatly relies on data centers. So data centers, they are all giant size. So data centers are nothing but the warehouse scale computers. So companies like Amazon and Google build these warehouse scale computers that contain hundred thousands of servers, and then let companies rent portions of them so that they can provide software services to the personal mobile devices without having their own WSCs. Okay, so this PMDs and this WSCs has a greater impact on hardware industry. So how this PMDs and WSCs are having the impact on hardware industry? The software as a service, it also has a greater impact on software industry. So what is the software as a service? In the sense, it delivers the software and data as a service over the internet, usually via a thin program such as a browser that runs on local client devices instead of binary code that must be installed and runs wholly on the device. Examples like web search and social networking or the software as a service. Okay, so today's software developers will often have a portion of their application that runs both on the personal mobile devices as well as a portion that runs on the cloud. Okay, so far we have discussed about the need for this vibrant industry, and in the upcoming lectures we shall learn about what is the need to study about the design or the architecture and the organization of this computer system. Thank you.